Today we're going to talk about our first lesson on proportional reasoning. Now we said before, a proportion is basically what? What's a proportion?
Oh, it's with two equivalent things.
That's perfect. When two ratios are equal. So when we see something like 1 over 2 equals 3 over 6, can we throw that away and then 6? Thank you. We have essentially a proportion, right? Because we know these to be equivalent. And there are a couple of different tests that we can apply to see if they are equivalent. I don't know how you found it, but can we just sit down at our desk and be in 6th grade? That'd be fantastic. Thank you. Okay. Now, we know that these are equivalent for a number of different reasons. And I understand that's a fairly basic one, but I want you to understand something. There's some rules about solving proportions that I want you to follow. And not every teacher teaches it this way. Some teach you only one way to solve proportions. I'm going to teach you 3 ways to solve proportions because I want you to get in the habit of looking for these 3 ways. Okay, and then we'll get into our assignment will be done. Okay? We know that these are equivalent for 2 reasons. One is something called scale factor. One is something called scale factor. And what scale factor basically says that if you're getting from one fraction to the other by multiplying or dividing by the same number, then you have equivalent fractions.
Oh, that's pretty simple.
If you multiply the top and the bottom, or divide the top and the bottom by the same number, then you have to have equivalent fractions. That's a guarantee. Okay? And if you notice, it's 1 times 3 is 3, and 2 times 3 is 6. 3 would be your scale factor that would ensure that those 2 things are equivalent. If you have, for example, a fraction that's 2/3, and I said apply a scale factor of 5, then you would end up with 10/15. Top, bottom. Scale factors are always using multiplication. Scale factors only use multiplication. You'll never divide with a scale factor. So my question is, when you have...
Well, you can only divide by a fraction, which will decrease the value. Or decimal.
Hold.
You still decrease the value. Right?
What's the scale factor to go from the left to the right?
Divided.
Labib?
5.
Wrong, because 10 times 5 is not 2. Jaden? Wrong, because 10 times -5 is -50. Jonah?
Times 1/5.
Times 1/5. Your scale factor, as I just said, only uses multiplication. You cannot divide.
You can decrease the number.
Well, you can, but the point is on a test, if they give you these 2, and I can tell it to you, if they give you these 2 fractions and say what scale factor takes you from the left to the right, I'll guarantee you answer choice A is going to be what? 5. Guaranteed. And if you choose it, you are wrong, because scale factors only use multiplication, which means that the scale factor is 1/5. Ty, what was your question, babe? Okay, we'll turn that into the office in just a second. Thank you, babe. Okay? Does everyone understand how you would get 1/5?
Yes.
By the way, there is a shortcut to doing that. If you know what you're going to divide by, you just use its reciprocal, the multiplicative inverse. Yeah, it does. So any questions on this? Secondly, after scale factor, the other way that we know that those are 2 equivalent fractions is through cross products. If the cross products to any 2 ratios or fractions are equivalent, then you must have equivalent fractions or proportions. 3 times 2 is 6, 1 times 6 is 6, therefore they're equivalent. Okay? No more butterfly method, cross products. Okay? Now the reason I'm showing you this is this. When you set up a proportion, where one of the numbers is missing, one of the values is missing. So for example, 2/3 equals x over 12. There are 3 ways I want you to solve. I know that you know what it is, but I just want you to watch. The first way I always want you to attempt is you look left to right and see if you can identify a pattern. If you look left to right and you can find a scale factor, in this case the scale factor is 4, then you do the same to the top as the bottom, and it gives you your x value that creates your proportion. It is very simple. Okay? So, the other way, everyone get that. By the way, you can also go right to left. You can go left to right, or you can go right to left. So the first way you look is left to right, same to the top as the bottom. The second way I want you to attempt to solve a proportion is this. Give me a second. Okay. Sometimes, now I know that some of you may see the scale factor, but if you don't instantly, Christopher, see the scale factor, if you don't see an easy way to get from 9 to 21 using multiplication, then you have another option, which is our second option. And our second option is you can simplify your given ratio and then look left to right. 6/9 simplifies to what? 2/3.
Oh, okay, I see how.
And now, is there a way to go, what is our scale factor now? Scale factor is 7. Therefore, x equals 14. Therefore, x equals 14. Alex?
The missing number is always going to be a multiple of the scale factor, right?
No. Oh, yeah, it'll have to.
Well, yeah.
Yeah, it has to be by definition. Yeah. But if you don't know what the scale factor is, that information does you no good. Okay. So, first look left to right. Same to the top as the bottom. Second way you do is you simplify, and then you look left to right. If all else fails, then you're stuck with the third and final way, which is cross multiplication. Cross multiplication creates for you a situation, a one-step algebra problem that you can then solve. So let's just say for giggle's sake that I did all this and I was like, I still don't see my scale factor. Then you would multiply this times this, which is what? What is 3 times x?
9x.
What is 3 times x? We simplify. We don't 3x. And you set it equal to 21 times 2, which is?
41.
It is not.
42.
It is 42. And it creates for you a one-step algebra problem.
3 times x equals 42.
And to find the value of x, you would divide both sides by 3. These cancel, and x equals 14. Now, sometimes that's what you're stuck with. Cross multiplication. By the way, a shortcut way of doing that is, say you had this. 8 over 3 equals x over 10. Is there a way to go left to right? No. 3 to 10? Not really. There is, mathematically, but it's not the easiest way. Is there a way to simplify 8/3? There is not, so we are stuck with the cross multiplication. I want you to watch a kind of shortcut version of doing it before we get to algebra. You connect the two numbers that you have on the diagonal through multiplication. What's 8 times 10?
80.
80, and you divide by the number that's left over.
Wow. That's so much easier.
Now watch, 3 times 2 is 6, we subtract, we get 2, we bring down our 0, that's 6 times 3 is 18, you subtract, you have 2 left over. At this point, listen very carefully, unless you're doing money, which requires decimals, I would right now take this, put it up top, take this, put it on the bottom, and your answer is x equals 26 and 2/3.
And then you would have to 3 times 26 plus 2, right? No.
So you're done.
That's your answer.
I was looking for the value of x.
Oh, okay.
I found it. Bennett.
Why is there, if that here is x but 26 with 2/3, oh, but that's kind of,
Bennett, take that out of your nose because it's distracting for me. Keep asking what?
it's like, why do you have a fraction over a fraction? Like
It's just because the value that makes these two equivalent for x would be 26 and 2/3. Oh, and by the way, if you doubt it, I'll show you. So what we're basically saying is that 8 over 3 equals 26 and 2/3 over 10. So let's just check that. What is 8 times 10? We know that that's 80. So what we really need to find out is what is 26 and 2/3 times 3? Now we have the mixed numbers, right? So I'm going to do the Texas method. 26 times 3 is 78, 79 is 80, over 3 times 3 over 1.
240 over 3.
Or 80, which is the same as 80. By the way, Labib, you cross-simplify before, right? Yes, sir.
I just never really seen a fraction.
Welcome to upper level mathematics.
So
And by the way,
by the way, to the left, that's it, I don't care.
Bennett, you'll also start seeing decimals. Bennett, you'll also start seeing decimals in fractions.
I already seen that.
Right. So it would stand to reason that if you see decimals in fractions, you're going to see fractions in fractions.
So that's the same thing as 26.6 repeat over 10? Yes.
Listen up. What were you saying, Brendan?
So that's the same as 26.6 repeating over 10, or could you
Yes.
not do a repeating?
Do not, if it's, here's a suggestion. You can do repeating, but you couldn't check it then.
Yeah, but it's
No, just listen to me.
okay.
Because if you do 26.6 repeating, and you did it times 3, it wouldn't exactly equal 80. Why not? Because 26.6 repeating is an estimation. It's not a real exact number. So in that case, you really need to use the exact number.
Okay, but could you have a repeating number over a fraction?
Yes.
Like, so you could have point like 6 over 10,
Yes.
like 0.6 repeating.
Yeah,
over
but
10.
0.6 repeating is equal to what fraction?
2/3.
So what you would need to use 2/3 if you're going to check your answer to make sure it's exactly right. First, Jonah.
Is it possible to have a fraction over a fraction over a fraction? What? Oh, I don't know.
Yeah. Mathematically, because every fraction is just what kind of a problem?
Division.
Is it possible to take a fraction divided by another fraction and divide by another fraction?
Yes.
Every fraction is a division problem. Gavin?
Is making 2/3 into a fraction the only way to make it an exact number?
Yes. Any repeating decimal is really a fraction. Okay? 1/9. By the way, 1/9 repeating is 0.1 repeating, but you wouldn't want to use 0.1 repeating, especially when you try to check your work. Now, here's why we're talking about this today. Today we're going to do one worksheet on unit rate, then you're going to be done. Now, unit rate, if you remember, is anything over 1, which means that you now have the option, Cameron, can you hold on that for me? Which you now have the option of setting up a proportion when you're given a unit rate. So it says, for $1.75, you spend $1.75 on 7 items, whatever those are, and it says, what is the unit rate? Well, you could set up a proportion, just make sure that it's over what? 1. And you're basically going to end up as this times this, which is 1.75, divided by 7 to get your number. If you're doing money, I want it rounded to the hundredths place, because that's the way money is always presented. Okay? Which means you have to go to what place? The thousandth place. Yeah, you have one worksheet, it's front back, but there aren't very many problems, and when you are done, You are done. Oh, by the way, one other quick thing. Please make sure that you are boxing your answers, because some of you in your sea of numbers, it's giving me a headache trying to figure out where your answer is. So I'll probably just default and count it wrong because, you know, I got the degree and you don't. So box your answers. I will not be looking in your sea of scroll nasty, writing with your feetness to look for the answer. Bennett?
Just,
Yes, I'm going to count yours on you.
just because you have a master's degree doesn't make a difference.
It makes me smarter than you.
But it doesn't make a difference with counting the grades, though.
Yes, it does, because I'm in control and you're not. What?
It still doesn't.
I'm the person who's being paid by the school district to fill out the grade book, and you're the one that's being, I don't know, told to sit here and take the grades that I give you.
Yeah.
What?
It's slavery.
Yeah, it's similar to slavery.